Here's another strategy that attackers can use to make network denial of service more powerful, and it's called an amplification attack. So far, when we thought about overwhelming network resources, it seems like the attacker and the server are on somewhat even playing fields. If the server has 10 megabytes per second of capacity, then the attacker has to send more than 10 in order to overwhelm the server. So in other words, the attacker has to buy up to 10 megabytes per second of bandwidth in order to attack the server. And if the server upgraded to 100 megabytes per second, then the attacker would also need 100 megabytes per second to overwhelm the server. So it seems like the amount of bandwidth the attacker needs is pretty similar to what the server needs. It's a pretty symmetric problem and doesn't seem like the attacker has an advantage. But here is one way for an attacker to get an advantage. They can use something called amplification. And this leverages the idea that some services send a large response when they see a small request. So here are some examples. Think about DNS requests. When you send a DNS request, it's pretty small. It has maybe one record that asks your question. What about the response? The response is big. It has the NS records, the additional records. There could be 13 of them for redundancy. So the response that you're getting could be 30 times larger than the request that you sent. So in other words, there is some server out there that accepts small requests and sends back large responses. So what if the attacker could somehow leverage those servers to get more bandwidth without having to pay for it themselves? That's the idea behind amplification. And the key idea that makes it work is spoofing. So here's an example where we will leverage a DNS name server's bandwidth to target some server. So the attacker will send a request to the DNS name server asking for some IP address. We don't care what the IP address is. We're just trying to overwhelm someone with bandwidth. So the attacker sends a tiny little question. It's just one record. But if they sent this packet normally, the big response would come back to them. And that's not so useful. We want the big response to go to the victim server because we want to overwhelm them. So what the attacker can do is take advantage of spoofing. Instead of saying that the packet is from the attacker, let's lie and say that the packet is from victim to server. That's a lie. This is not really where the packet is coming from. But when the DNS name server sees this packet, where does it send the response? Not to the attacker. The attacker's identity is nowhere in the packet. Instead, the name server generates a big response, 35 records, and sends all of it to the victim. And now this victim server is responsible for processing 35 DNS records. So what happened here is that the attacker spent just a little bit of bandwidth, maybe one packet or one record, but they were able to cause the victim to process 35 packets, or however many were in that big response. That's where the amplification comes from. The attacker spent just a little bit of resources or bandwidth to send its request, but the victim had to process a really big response as a result. And the attacker didn't have to pay for that extra bandwidth. Somebody else, like a DNS name server, was already providing that extra bandwidth, and the attacker has leveraged it for their attack. So this is what amplification looks like. It could be done with DNS. It could also be done with other services, but they all come down to the idea of spoofing a small request and causing a large amount of data to be sent to the victim you're trying to attack. So why would someone want to use amplified denial of service? Well, we already saw that it gives the attacker more power. So now there's starting to be some asymmetry in favor of the attacker. The attacker might be able to spend 10 megabytes per second of bandwidth and still take down a server with 100 megabytes per second of bandwidth. So the attacker spends 10, but they're able to take down someone with 100. There's more asymmetry there. Also, another nice benefit that you get as an attacker is that your identity might be concealed. If you think about this picture, the victim only sees a packet from name server to victim with a bunch of bogus records. Nowhere in here do we see the attacker's name. So by using spoofing, the attacker might also be able to hide their own identity, and this way they might avoid being caught or being blocked. That could be a benefit for amplification as well. Now, one drawback is that you have to be able to do spoofing, and sometimes this is possible, sometimes it's not. So for example, if you think all the way back to TCP attacks, we said that TCP spoofing is generally pretty hard. It's hard to start up a new connection pretending to be someone else. So these attacks are usually most effective on UDP protocols like DNS, where spoofing is easier.